Now let's learn about the database service of AWS called RDS. RDS stands for Relational Database Service, and it's basically a managed database service so that your DB is managed by AWS and you can use SQL or SQL as the query language. Basically, it allows you to create databases in the cloud and managed by AWS so you don't have to do much. The databases you can create are Postgres, Oracle, MySQL, MariaDB, Oracle, Microsoft SQL Server, and Aurora. Aurora, you may have heard of it. It's basically AWS's proprietary database technology. Okay, we'll do a deep dive onto what that means. So why would you use RDS versus, I don't know, maybe deploying your own database on EC2 with maybe EBS? Well, it's a managed service, so you get a lot out of it. You get OS patching, you get continuous backup and restore and being able to restore to specific timestamps. You get monitoring dashboards. You get read replicas if you want to improve the read performance. You get multi-availability zone setups for disaster recovery. You get maintenance windows for upgrades, and you get scaling capability if you want to scale it vertically or horizontally. And the only drawback is that you can't really SSH into your RDS instances. You have to understand that Amazon manages them for you, so you don't interact with them directly. So honestly, I would not think about it twice. If I have to use a database on Amazon, I will use RDS. I will not set up my own database on EC2 because of all these good things we just saw right here. So what I want to do is just give you a little bit of deep dive into a few features, read replicas, multi-AZ, backup, etc., just to get a better understanding of how things work. So read replicas for read scalability is basically the idea. You have your application and you have your RDS DB instance. And this is how the writes and the read happen. So when you first set up RDS, this is what happens. You just have one application or multiple instances of your application and one database instance, and all the reads and all the writes go to there. But sometimes, after a while, maybe you realize that your application needs to read a lot from your database, and so you need to increase your read scalability. So what happens is that you can create read replicas. And using this feature, you can create up to 5 read replicas. These read replicas can be within the same availability zone, or cross availability zone, or cross region. So you can create an RDS instance replica right here, one right here, and it turns out that to replicate the data between the master instance and the replica instance, it is asynchronous. So asynchronous means that the reads will be eventually consistent. So that means that when you write to the master, there will be a small lag, a small latency, a small delay between when the write was happening in the master and when it will be replicated to the replicas. Okay, so this is something you should know. The replication is asynchronous. The replicas themselves really help with the read capability, so your application can now scale and reads. And the replicas, if you wanted to, could be promoted to their own database. It's a very quick and easy way to replicate a database and work with something on its own. The application now, something you should know, and it's sometimes asked in the exam, basically the application needs to change the connection string to leverage the read replicas. Okay, it's very important. Now, out of this setup, you'll get 3 connection strings, 1 for the master and 2 for the replicas. And so your application needs to be aware of it. So read replicas, if you remember, 2 things. It is multiple instances. Only one, the master takes the writes, all the other one takes the reads, and basically the replication is asynchronous. Okay? Now, this is something that you have to contrast with multi-AZ. And multi-AZ is for disaster recovery. So multi-AZ is basically your application still talks to the master database instance. Maybe it will be in availability zone A, and it'll do all the reads and the writes. And it turns out that this master DB will have this time a synchronous replication to one DB instance that is called the standby, hence the name S. And that instance will be in AZ B, okay, or C or whatever you want. And so basically the idea is that only one DNS name will be exposed to your application, and that DNS name will have an automatic failover from the master to the standby in case there are any issues. And why would you do this? Well, it's to increase availability. So if a whole instance goes down, if a whole loss of an AZ go down, or network or instance or storage has a failure, basically our application can fail over from the master to the standby, and the standby will be promoted master, okay? And for this, There is no manual intervention that needs to happen in your applications. It will happen seamlessly. And so the only thing why you would use multi-AZ is for disaster recovery. As you can see, our application still reads and writes to only one database. And to make sure that you can failover seamlessly, the replication is synchronous, okay? So this is not something you use for scaling, this is something you use for disaster recovery. So this is really the difference between the read replicas, which is used for read scaling, and the multi-AZ, which is used for disaster recovery. And you can use, obviously, a combination of both. Now, backups. Backups are automatically enabled in RDS. And they're automated backups, so there's a daily full snapshot of the database. So every night, there will be a full snapshot of the database to make sure we know where it is. And then all the transaction logs are captured in real time, so that using that transaction log, you're able to restore to any point of time your database. And that's quite a nice feature. All these backups are retained for 7 days, but you can increase this to 35 days. And that's all for it for the automated backups. And so this is just enabled for you. You don't have to set up anything. And the really good thing about it is that you're able to roll back to, say, 2 p.m. yesterday very, very quickly, and being able to, save your applications in case of problems. Now you can also trigger manual database snapshots, and they're manually triggered by the user, and the retention is for as long as you want. So you would do this if you need to know that there is a state, a very, very particular state that you need to save, or you want a long-term backup for whatever reason. You would use database snapshots. Now on the security side, super important, and that's, the exam really loves security, so you need to be aware of all the security stuff. So the encryption is at rest, and again, we see KMS being mentioned. So there's encryption rest capability. You have to enable it using KMS, and it'll give you the AES 256 encryption. You can also use SSL certificates to encrypt data to RDS in flight. Okay, so that's the contrast. At rest means on disk, in flight means over the network. And so to enforce SSL, and that's quite a popular question, for Postgres, there's one parameter we can set in the RDS console in parameters group, and it's called RDS.force_SSL equals 1. That's for PostgreSQL. And for MySQL, within the database, you have to run this statement. And it's quite a complicated statement. But what you notice is that at the end, it says require SSL. So that's to enforce SSL. Once you run this statement, basically no user will be able to connect to MySQL unless on SSL connection. And so that's quite a popular question. Now, if you want to connect using SSL, how do you do it? Well, you provide the SSL trust certificate that you can download from the AWS website. And then you provide the SSL option when you connect to your database. And that's about it. It's quite simple. But you need to know the difference between enforcing SSL and connecting using SSL, okay? Connecting using SSL doesn't mean that SSL is necessarily enforced. So knowing how to enforce SSL is something you should know and make note of. Now for security, RDS databases are usually deployed within a private subnet so that you don't expose them publicly. And RDS security works by leveraging security groups, as we'll see. So basically, security groups allow to understand who, like which IP or which other security group can communicate with RDS. In terms of who can manage RDS, for this we'll use IAM policy. And for connecting and logging into the RDS database, so actually making operations within the RDS database, we'll use traditional username and password, or you can also integrate it with IAM users. This is new for MySQL or Aurora, okay? Something you should know about. Now, talking Aurora, just a last bit you should know about RDS. Aurora is basically a proprietary technology from AWS, and it's not open source, so we don't know how it works. But basically, Aurora is compatible with Postgres and MySQL, so they're both supported. And the idea with Aurora is that it's cloud optimized. And so Amazon claims there is a 5x performance improvement over MySQL, or a 3x performance improvement over Postgres. And it comes with like incremental storage, so you can increment the storage over time from 10 gigabytes up to 64 terabytes. It can have 15 replicas with MySQL, and you can do replication faster, like it says sub 10 millisecond replica lag. And also there's failover, so it's multi-AZ by default. It's high availability native, so your application will failover directly. And although Aurora costs more than RDS, a bit more, it's said to be more efficient, and so overall your cost should decrease. with this Aurora database, basically Amazon is trying to push a technology that's going to be a bit less painful to set up, a bit more scalable, and a bit more cloud friendly. So there's not that many questions about Aurora in the exam yet, but you should still know about it and what's the difference between RDS and Aurora. Aurora is going to be a proprietary technology from AWS, comes with a lot of goodies, whereas if you want to set up Postgres or MySQL and RDS, then you have to set up the read replica and the multi-AZ as options if you wanted to. Okay, so that's all for RDS. In the next lecture, we'll go ahead with the labs.